This problem that we're about to do is identical to the problem that was given as extra credit, where we have a block that is on a surface with a coefficient of friction given as mu k attached to another block over a pulley, and we wish to know the acceleration of our system. We'll start by drawing a free body diagram for block A. So let's do that right over here. We have block A, and we're going to say that for block A, we've got a tension force off to the side. We'll label that Ft. We've got this friction force, F of F, off to the left. We've got our weight down, F. I'm going to specify it Fg sub A. And we've got our normal force up, Fn. Now, looking at this free body diagram, now we're going to create some equations from Newton's second law. If you'd like to test yourself to use this diagram and create some equations, go ahead and pause the video and see if the equations that you come up with are the same as the equations that I'm going to come up with. I am going to declare that positive x is to the right. Now, the equations that we get from this free body diagram would be the following. We would have that the sum of forces in the x direction would be equal to our tension off to the right minus the friction force, and that's going to equal the mass times the acceleration in the x direction, and that's specifically the mass of block A. And then in the y direction, just for completeness, because we will need this normal force, sum of forces in the y direction, it's going to be my normal force minus Fg sub A. And that's going to equal the mass of A times the acceleration in the y direction, but we know that that's going to be 0 because we don't expect it to be moving up or down. For block B, then, if we were to take block B, our free body diagram for that would just have an upward tension force that's the same length as the tension force that was in the free body diagram for block A, and then a downward weight force, Fg sub B. I'm sure here to draw this Fg sub B bigger than F of t because this will be accelerating as it travels downward. Here we will declare positive x to be down. That allows us then to say that the sum of forces in the x direction for this object, there's an x there, is going to be Fg sub B minus Ft, and that's going to equal the mass of block B times that acceleration in the x direction. So we actually have this as one of our equations that we can then pair with this equation here to get our unknowns. We know that for our friction force, this equation should become Ft minus mu times the normal force. This equation tells me that the normal force for this case is going to be equal to the mass of block A times g, right? So just for clarity, this friction force is this, and this is the normal force, right? Friction force is defined as mu times the normal force. So then we're going to have F of t minus F of friction equals mass A times AX. So then we have a system of two equations, two unknowns, where we would solve for one of those. I would solve for, probably in this equation, I'd solve for F of t first to get that F of t is going to equal the mass of block B times G, that's FGB, minus the mass of block B times A in the x direction, and then I would substitute this term into this expression here for F of t to have only an expression in A. So that should get you started, and should get you to an answer for the acceleration of that block. Here I've just solved it symbolically. If we had numbers, we would put them in appropriately.